Okay, it's lovely to be here. Thank you very much for having me along. It's as soon as I heard there was a gathering of the tribes of strongly typed functional programming, I thought I really want to come to that conference, and it's really great to see a strongly typed functional programming conference kicking off. I hope this is a start of really a great future for the Compose conference. I think there's so much. I've already learned a lot just from this morning. Really great to see David Christiansen's talk on type providers. I learned a lot from the first talk as well. There's so much exciting stuff happening in strongly typed functional programming, and I'm sure that's going to continue to be the case over the next 10, 20 years, and looking forward to Compose being at the forefront of that. Okay, so I'm going to be talking about contradictions, really. Talking about things from stories and aspects of my working life in the process of doing the design of the F# programming language, but some technical things and some cultural things as well, things which sort of take you in different directions, and how we can find a resolution of these tensions, these things that pull us apart. Sometimes I think this comes from sort of personal perspectives on my own life. I'm an Australian living in England, and my wife and my children are German, and I work for an American company, and on the West Coast, and sometimes I feel like this is taking me apart in many different directions, and it's a continual process of a wonderful and exciting and enjoyable process of finding resolution of some of those tensions into positive outcomes. And I think that's for many of us over the last 20 years, we struggle with that in our technical work in programming and programming languages, where so many things pull us in different directions, and we have to find positive resolutions. So it's a sort of gentle stroll through the land of language design and delivery. So I do think that we have to struggle with the great disputes of computer science, and they are a chance to make the world a better place, a better, simpler, more relaxed and happy place, if you can find good resolutions of these things. I think one of the people who really stands out to me in that is Phil Wadler. Back in 1998, when the object-oriented bandwagon had rolled through. Half of you weren't born, I know, back then. It was bad times, and they'd come into town and shot everybody up, and Phil stood there, and he didn't just in 1998, 97, he and Martin Adersky and some other people started a project called Pizza, which was about finding a resolution between some elements of functional programming and some elements of object-oriented programming, and that led to Java generics eventually, and that led to me doing .NET generics on my little part of the world, and that led me to working on a functional programming language in the context of .NET originally, and so but it was Phil and Martin Adersky and others who really stood up and started a great stream of work of finding these resolutions, which has continued, and many other people as well, but I remember them particularly. Now, when I've mentioned this, some people immediately put up their hand and say, "Yeah, but what about Emacs and VI?" They're really important disputes. And that one I can't work on. I'm afraid that's for someone else to resolve. What's that? Yeah. Yep. Okay. The answer is here. The answer to that one, the great one, is to be found here. Okay, so finding sort of a synthesis out of thesis and antithesis is not a new idea. It goes way back in Western philosophy, and some people put this at the core of their belief systems, that this is what sort of life has to be about in all its aspects. So you can perhaps take this idea a little bit too far. When I mentioned that I was doing a talk on this topic to Thomas Petracek, who some of you might know, he said to me, "Ah, right, you mean mustard and you mean mustard watches?" I go, I guess that's what I mean. Okay, so, right, so he told me about this famous French abstract about resolving this tension between the concept, what is it? There's time and watch time, the mustard watch, a common generalization of the watch and the mustard pot. Okay, so so you can take that a little bit too far. So it's always good to stop and ask whether these are true tensions or if we're just mucking about. Okay, so in the talk I'll go through some tensions and talk about the resolutions that we found. And I'll go back to the one that started it for me with F sharp, which was not really about mixing functional and objects, which was what the pizza work was about, but really about functional programming and interoperability, which is really why we started F sharp. So back then, in 2003, functional languages were really isolated, non-interoperable. They were all using their own VMs. That actually, funnily enough, is seen as a little less problematic today. It's still the case for some functional languages, Haskell and OCaml, for example. But it was very problematic back then. The interop standards were all about CCalls, COM, Corba, XML. Things were a complete mess with regard to for language integration. And then a lot of things changed, and the approach, which is well known now from F sharp and Scala and a host of other languages, is about embracing industry standard runtime layers, influencing them as much as we can. There's a very interesting tension there about how close you get to the when you move into working on the JVM or in .NET, you're in the context of this exosystem around you, this big monster of a thing, which is the .NET ecosystem or the Java ecosystem, and how close you get to that ecosystem is a finely tuned thing. Difficult to get that perfect. I think there's tensions in both directions there. It's interesting to kind of look at this as a theme in programming language design and delivery, and look at how new languages like Swift are balancing this. Swift is moving into the Objective-C iOS, app development ecosystem. And when I look at Swift, I think, oh, maybe it's gone a bit too close to that ecosystem, which is very strongly tied to a particular platform. I think, in retrospect, I would have said the same thing about F sharp originally. .NET is now fully open source and available on pretty much all platforms. You can do .NET programming for iOS and Android devices and all sorts of other things. So I'm a bit less concerned about that now. But it's just interesting. It's an interesting theme in programming language design about how you achieve the resolution between interop and functional while working with this exosystem. So some compromise is needed there. And so the end result, however, is absolutely wonderful. We're in a completely different position when you come to F sharp or you come to Scala these days, in a completely different position to where we were in 2003. They're immensely interoperable while they stay true to functional programming principles. The F sharp, interestingly, that notion of interoperability has fed into a new iteration of work in this F sharp type provider kind of work, which I'll touch on later, kind of raises the notion of interoperating with the external exosystem to a completely different level. It's certainly true some tensions remain. This is not a complete resolution. It's certainly enough to give a notion of relaxation, that you don't have to worry about where your Unicode libraries are coming from. They're just there. Yeah. And again, where are your high quality networking libraries? They're just there. Where's your Amazon SDK? It's just there. It's just everything just kind of works. But some tensions do remain. So not all functional techniques functional programming language techniques are easily implemented on standard industry VMs. The one that people always hit F# about will be higher kind of type parameters in Haskell, which aren't implementable on the system of .NET generics. There are some benefits with not having that in your language as well, it must be said, in terms of what topics tend to dominate your discussion lists, in your email exchanges. So there are some benefits, but there are some loss of expressivity as well. But the vast core of functional programming techniques carry across extremely well into the .NET, and I'd say in Scala, in the Scala environment as well. But I'm of course focusing on F# here. Okay, so that's the functional and interrupt theme. The next theme I want to talk about is a more cultural theme. As I said, I want to mix both technical and cultural things here, and the tensions. And it's a tension, I think, which is massive in the computer industry, and which we need to talk about more as how we all find our different resolutions in this combination. And that's the themes of enterprise and openness. And just to get straight to the point of where we are now with F#. So F# itself as a language is independent, open, and cross-platform. And that's as languages should be. I think everyone in the audience is going to be agree with that. We're not into proprietary languages here, and F# is certainly not a proprietary language. So the F# language is on GitHub, accepting contributions. You can go along and contribute to it today. I'll talk a bit about more about that in a moment. And there's a fabulous software foundation associated with F#, which is the F# Software Foundation. You can find out more about that up here on fsharp.org. And in a sense, the F# Software Foundation is what every language should have, which is a strong and independent voice driven by the community itself for the language. Although F# has a history at Microsoft, and it started at Microsoft Research, in the end, it's the people who are using the programming language who have to be the voice for the programming language. And I think we actually see that even if you take a language like C#, where Microsoft is, of course, a strong interest in C#, but in the end, I actually think C# lacks a strong voice for the language itself. And there should be a csharp.org, and there should be a C# Software Foundation, which is independent and very much driven by the community itself. And that's what we have with the F# Software Foundation. Everyone can sign up and join. It's free to join, and you can also join as a voting member, I think, which costs a little bit of money. But that's because of US laws and regulations to join as a voting member. If you're interested in finding out who the members are, then you can take a look here. There are about over 300 members of the F# Software Foundation now. It's a non-profit, so you can. It's an open, community-driven one with. It's not a closed membership; it's an open membership. I don't know what that maps to. You can ask them because I'm not on the. I'm not doing any of the legal stuff for that. But I think it's the one you'll be happy with. But you can check. Okay. So the board is elected, will be elected. They'll be coming up to their first election sometime soon. So if anyone wants to stand for election, please do. Okay, so on the enterprise side, we have Xamarin providing F# tools for Android and iOS. And so that's Xamarin Studio. We have the Visual F# tools as part of Visual Studio, shipping to millions and millions of programmers worldwide. Which are the professional tools for Azure and Windows. And of course, we have the Debian and other packagings for Linux. Okay, in the sort of more ecosystem side of things, we have this wonderful component called the F# compiler services. And that's really powering an interesting sort of explosion in tools for doing interesting things with the F# programming language, and you saw the iHaskell earlier on. We now have, which is iHaskell integrated with the IPython environment. We have the F Sharp, similar thing, being driven by Rick and some people at Bayard Rock. And that's using the F Sharp compiler service underneath. I'll give some more examples of how this is allowing, this component is key to me in this kind of picture, in that it allows F Sharp to travel to many other places where it's not already present. You know, F Sharp was originally in the Visual F Sharp tools, but now F Sharp, through the F Sharp compiler service, is going on to the Mac, is going on to Linux, it's going into Xamarin Studio, is going into IF Sharp and IPython, and maybe the successors of that kind of tooling, and more places than that as well. So it's absolutely crucial tool to allow the language to kind of spread. So the F Sharp community is a wonderful self-empowered set of people. They really feel a strong sense of ownership of the destiny of the language and the community, and very, very helpful community, and wonderful to be part of. And all of this position, which I think is a really great position to be in for the language, is allowing me to get back to what's actually my job, which is to concentrate on the language design and the core of what it makes up F Sharp technically. So that's allowed me to concentrate on doing an F Sharp 4.0, which was F Sharp 4.0 is in some ways about a set of cultural transitions to allow F Sharp to be more open and cross-platform, and a set of technical features as well. So that in a sense is a summary of the kind of transitions we've made over the last year. So F Sharp Software Foundation is a voice for F Sharp. We have F Sharp in a range of different IDE tools. In Emacs and Vim, you get IntelliSense and red squigglies and all the nice tooling in Emacs. And the F Sharp compiler service I've mentioned, plus this excellent set of additional tools for doing Visual Studio development with F Sharp called the Visual F Sharp Power Tools. Then I think there's been a big shift. It's been a huge shift from Microsoft. I mean, I don't know if people have seen just how much Microsoft is embracing open source. This really shocked me actually when I looked at this list. It's just a lot of stuff, and that's the first of 5 pages there. So lots of stuff coming out from Microsoft, but even more importantly, and predating that shift, the F Sharp community had already shifted to being an open ecosystem where people were contributing all sorts of stuff completely independently of what Microsoft was doing, and really nothing to do with Microsoft. So there's been a cross-platform shift in Xamarin, Debian, OS X, WebSharper for HTML, FunScript for HTML, and Alia for GPU. And now everything is open source. We do open engineering on absolutely everything, all of F Sharp and all of the Visual F Sharp tools from Microsoft and all the other things I've mentioned as well. Okay, it's still part of Visual Studio and an enterprise-supported product as well. So the F Sharp compiler, the part that I'm mostly focused on, F Sharp compiler and language design, I've had 160 pull requests and rising rapidly. Okay, so if you want to learn how to contribute, then fsharp.github.io is a good place to start. That gives you all the guides. Okay, I'll bring that up briefly. That is the F Sharp core engineering group here. And that's really just a group of us who are sort of an umbrella for the people who are working directly in the GitHub repos of F Sharp. Okay, I'm actually going to very quickly explain what this is. You won't be able to read the slides, but it's roughly showing how things flow through the system, so that if you contribute to the F Sharp compiler, the language and library, we actually ask that you first submit to this set of repos managed by Microsoft. And there's a reason for that. I mean, ideally, we kind of in some sort of ideologically ideal world, we wouldn't do that. But the crucial thing is that Microsoft actually QA everything that goes into here at full Visual Studio QA quality. It doesn't mean there aren't bugs, but it's a really high bar to get into here. Okay, and that's so important because it means anything that comes through here is gone through that gate, and as it flows through the rest of the ecosystem can be pretty strongly trusted. And so Microsoft packaged the Visual F# tools for Windows and Azure and so on down there in the major Visual Studio releases and daily builds and things like that. You can get daily builds. Down here, so what you contribute, you can quickly use if you wish to go down that path. This stuff also gets pulled across to the F# compiler service open edition, and they get published as a set of packages called the F# compiler service packages. And those packages are at the core of a whole lot of work. Here, just two examples. One is the Visual F# Power Tools, one is these F# Open Editing Tools, but about another 20 consumers of these packages here. And so what it means is as you make a contribution, it can get pushed across, a new package release can be made, and people can synchronize to that new package release, and you'll be updating the F# language being supported around the fringe, or updating the set of services available and throughout all this tooling around the outside. And this takes us to Emacs packages and Xamarin Studio and Mono Develop and some other things as well. So you can see the end picture here is there's a number of players involved, sort of legally. We have enterprises, we have openness, okay? We have open and community-driven efforts around as well. But there's a real unity to what flows through here as well. There's Git relationships between all of these. A contribution here can flow through the ecosystem, technically speaking, in half an hour, if necessary. We could arrange for a contribution to flow through that fast. Okay, I'll skip that part. Okay, so we have an open language design process, which I'd encourage, a lot of people are interested in statically typed functional programming, so please come along. Even if you don't use F#, come along to the F# language design user voice and vote and give your opinions and technical input and feedback as well. I use this a lot. Some people are saying it's crowdsourcing program management, that it really does help to see how many votes things are getting. And I do mark things as planned and completed and so on as various items go through the user voice design process. And the F# 4.0 feature set was definitely driven partly by what was on here. It's not a democratic process in the end, but we do definitely use that information to feed into the design process. Okay, I mentioned the F# compiler service. And this is the sort of thing that's in the territory like every language should have one of these, okay? Even before you write your compiler, you should write your compiler services and just have your compiler be a little thunk shell around the compiler services. You can see the services. It's just a DLL. It's a single file, which is, the F#. It's called F# compiler service DLL. It's just a single component. It's got a tokenizer. It lets you look at untyped ASTs. There's a set of fairly high-level services for building editors, so for doing IntelliSense and autocomplete and things like that. There's working with symbols, expressions. You can analyze entire whole projects. Okay, so there's an incremental aspect to the computation graph as well, and that is important for hosting very large code bases in interactive tools. And there's F# Interactive itself, which is the REPL for F#. The core logic of that is in the compiler service. And you can actually use a compiler as a component to do compilation and evaluation. And finally, an interesting kind of aspect of this is that you can replace the notion of the file system that the compiler service is using. It's done by replacing a global variable at the moment. But you replace the file system API, and suddenly the compiler services are no longer accessing anything on disk, but are accessing a virtualized file system, and that gives all sorts of interesting uses of the compiler services, because there's no actual files being written. Everything can be in memory or to some other kind of store. So if we look at some of the uses of the compiler services, I've mentioned some of these. So we have IF Sharp and cloud-hosted or web-hosted programming for F#. It's being used to host game loops in game scripting, to make F# a great game scripting language in this FQuake 3. And there's some other examples of that as well, not listed here. It's used for hosting F# code as the programmability language for Excel in a wonderful set of tooling called FCell. And it's also being used through a set of literate programming tools. Most people are used to some form of literate programming. This is FS Reveal, which allows you to write a script full of F# code and Markdown, and instead of being converted to HTML, it's getting converted into these reveal.js slides. And so it's sort of literate code-oriented slides. Let's have a look at some examples here. So this is, so for example, when you're working here, what it means is you actually get like as your scripts, your F# scripts, documentation has been processed into slides. It's also preserving the information about the code, such as IntelliSense all the way through into the slides. Okay, so new takes on literate programming. So that's the F# compiler service. So all in all, this is really, for me, where we are with F# today is an ideal position to be in. You have enterprise quality, you have full openness, we have a wonderful community and a foundation to match that, great tooling, an ecosystem that's growing, and an evolution path to be able to take the language forward. And for me, those are the kind of key foundations that make an exciting thing to be part of. Okay. Now, the enterprise openness thing is one that just intrigues me. It's been amazing for me to be working at Microsoft, the ultimate enterprise company, and see it make the big flip towards openness on so much of its core work. And F# actually started down that path before Microsoft did that. We led the way in some ways, and that's been, I'm very glad to have done that. But I'm also just interested in hearing your stories, after the talk, about how your enterprise or your companies that you're working for are navigating the enterprise and openness kind of tension. Okay, so let's get back to a technical topic on functional and objects. This was sort of the second major technical topic that the F# language design had to encounter as it grew up. Inevitably, as if you're part of the .NET ecosystem, you have to be a good object-oriented programming language. Or I tend to say that F# is good at object programming rather than object-oriented programming. Okay, we do objects, you can program with them, but programming does not tend to be object-oriented. It's still we like to call F# a functional-first programming language. And then, so back then in 2003, functional languages were historically anti-OO. I could probably test that by just object. Oh, yeah, there we go. I knew, good, yes, I thought I would, yep. Yes, functional languages were historically very anti-OO, okay? And there's this awesome quote, the most beautiful part of any computer science book I've read, okay, which is that in this compiler implementation with standard ML, there are these little subtitles. How many people know the book or one of its other? Okay, check the little subtitles in each chapter. Okay, and they're all as dry as toast. There'll be things like garbage collection, removing unnecessary memory, blah, 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 something like that. And then, and in the object-oriented programming chapter, it's got that one, object, to express a dislike or distaste for something. And that is clear that those little subtitles were put in only for the purpose of being able to put that one in. Okay. So I love it. It's okay, so we didn't take that approach with F#. First I'll just mention what objects actually look like in F#. That's a class definition in F#. You can have inputs to the object construction with an implicit constructor. You have some object internals, which are just straight up OCaml F# style programming in there. You can more or less take a big chunk of F# functional programming and whack it in there, and that becomes sort of internalized to the object. And then you have kind of some public API down here where you have exported properties here and some exported members. This is the name for the this parameter. The this parameter here lets you kind of have a recursive reference to the object, so there's sort of some implicit recursion going on here without actually putting type rec or anything like that. So as you move more towards object-oriented programming, you start to get some of the object kind of things, one of recursion being one of them, as part of the sort of gadgets you can play with in your programming. And this is sort of what they look like. Constructed class types here, object interface types here, object expressions here and here. Now, it's interesting, object expressions are an example of a feature which C# doesn't yet have. Yet it's where we started with object-oriented programming in F#. Once upon a time, F# 0.4 or something only supported this feature and not the rest, because F# was an expression-oriented language, and the key thing is to start with the way that you start with the sort of thing that works most powerfully and augments the language in the most powerful way, and that's the expression-oriented features of that. So the F# approach is to embrace objects and make them fit with the expression-oriented typed functional paradigm, but not full object orientation. I mean, they're especially focused on interop and software engineering sort of metadata purposes. When it comes down to it, finding a reconciliation between functional and objects, at least for F#, sort of meant there's this whole lot of things which we think of as functional. Expression-oriented is one of them. Null not being the default, so non-nullness as a default is another. Multiple arguments is the same as tuples is another. Closure and capture is another. Being able to use things in a first-class way is another. Currying, maybe something in Hindley-Milner type inference is something here as well. And then we have all these things we think of as objects, subtyping or object types or dot notation or method overloading down here. And there's a lot of these have interactions. Perhaps some of them don't have an interaction, but there really are quite a lot of interactions all over the shop here. And my job really for a couple of years with F# was just to find good resolutions of these things so that there may be a bit of extra work in the F# language design. There may be some corner cases that are associated with finding a resolution, but on the whole, these things work extremely well in F#. There are some things which have a sort of graceful degradation kind of pattern. Hindley-Milner type inference just works as it does in OCaml for a lot of F# code, plus we have some additional constraints which are associated with method, with arithmetic sort of operators. So as you start to use more object features, then you need more type annotations. So it's a sort of pay-as-you-go approach towards finding a degradation here. And it'd be the same over here, so that, for instance, you won't be able to use a method as a first-class value, or you might need a type annotation if you're going to be using methods that are overloaded down here. There are some things which we actually outlaw, like using method overloading and currying, okay? We just decided that tension was too much. Let's just say, don't go there. Technically, you probably could find a resolution between those, but just say, no, we're not going to go down that path. Okay. So that's great. It was a big success. It is a big success in practice. And keeping an interoperable object-capable language while taking a functional first approach has been really technically very successful. There's just one anecdote which I like to tell about that, which is the difference here between a C# object-oriented, heavily OO design pattern team doing an implementation of pretty much the same set of functionality as an F# team. This is in the energy sector in the United Kingdom. It's, I think, a simulator in the energy market from one of the major power providers in the UK. And the C# project took 5 years, had 8 developers, et cetera, et cetera. And the F# project had 3 developers and was better. So some stats here, 56,000 lines of braces in the C# code. So we have 3,000 lines of null checks. Lots of good testing. The test ratio in the F# code is actually higher here, almost 1/3 being tests here. Should probably be about the same once you discounted the braces, I guess, or the white space. Yeah. Okay, so that's all good. Perhaps the one that is most compelling to me is this 2,000 lines of try-catch statements in the C# code, and very few lines in the F# code. To me, it says that the complexity, this is a reactive application, and to me, it says that the C# code just got completely out of control with regard to its complexity. There's some exceptions being thrown in exception handlers and then propagating throughout the code base, and then it was just a disaster. They got into the habit of putting a try catch around every single check-in just in case it was going to bring the system down, and then they didn't know where to send the exception because they were in a reactive setting without any monadic programming, etc., and it was just all catastrophe. And nice stats on 0 bugs in the deployed system. And so for these people, F#, and for these people equate F# with functional first methodology, okay, or functional methodology in general. So in some ways they're talking about, it's not unclear if they're talking about language or functional methodology. You can make your own choice. So he actually renamed the blog post from does the language you use make a difference to does the methodology you use make a difference. So functional and objects, we have a good positive synthesis there. There's one way in which we actually didn't find a synthesis, and that's about circularity and modularity. Okay, so this idea of mixed OO functional programming is definitely one. It's one absolutely sort of everywhere almost. So lambdas in C#, like etc. But it hasn't won everywhere in the sense that there's some, in these other languages, nulls are everywhere, inheritance is still everywhere, and circularities are still everywhere. So we all probably know that unnecessary circularities aren't particularly good. Since I'm running short on time, I just mentioned that the F# approach is to have a file ordering, like in OCaml and Haskell. F# prohibits direct circularities across files, and it encourages minimizing dependencies within a file. Okay, so this is an analysis of some C# and F# projects to look at the difference that it makes between a language where circularities are allowed anywhere within a sort of large compilation unit called an assembly, versus F#, which is where you have this linear ordering in your files. And let's just look at how the number, so this is analyzing the number of dependencies between top-level module/class level components in C# and F# projects. And you can see here in F# projects, the number of dependencies is much lower. This is based on a code size measured in the generated compiled code between C# and F#. And you can see in C# the number of dependencies is increasing and higher. So you see in F# projects about 50% of the components here have no dependencies. In C# that's about 30%. Now zero dependency components are lovely. Yeah, they're only depending on the sort of core framework libraries because they're completely reusable in other contexts. And you can see that if we look up here, 10 or more dependencies, there's only 2% here in the F# code. But perhaps of more interest is cycles. And what we'll take a look at here is the cycle counts down here and the maximum component sizes here. So you can see there's one C# project here with 123, with only 2 cycles and 123 components in that cycle chain. Or we take this entity framework, has 14 different cycles with the biggest one being 79 components. And compare that to the F# code, where we have the cycle counts down here, which are nearly always 0, and then the maximum component size being in the order of 1, 2, or 3. Okay, so let's take a look at what that means graphically. Here's a testing framework called SpecFlow, which is C# code. And you can see you see some use of inheritance here for something or other to do an AST of some kind. And you can see there's probably quite well-written C# code, but there are some cycles in there. I think this goes on for another page down below. That's the tick flow dependency graph for F#. No cycles, very clear structure. It's very nice. Okay, so circularity, this is the top level. This is the sort of display of the number of types participating in cycles here between the C# and F#. And this, perhaps most tellingly of all, is one of 12 pages of dependency graph for a thing called Microsoft Entity Framework. Okay, I don't know how anybody could ever work on that code base. Okay, it's really, I mean, it's used a lot. It's used very, very widely, but from the inside, it's a real beast, by the look of it, anyway. So in theory and in practice, I believe that unmoderated intra-component cycles are a disaster, and F# takes a strict approach, and it's somewhere we didn't find a resolution. And it's interesting to think for the future, what are other ways that this question could be kind of solved in this sort of applied programming language space. There are probably better solutions than just taking a hard line like F# has done, or taking a free-for-all like C# and Java have done. Okay, let's talk. I've only got 5 minutes left, so I'm just going to mention a couple of the other areas of sort of tension and resolution. And one of the most important for type functional programming, I think, is pattern matching and abstraction. So we all love pattern matching in these languages. You know, patterns are everywhere in F#. Even in the object-oriented programming here, if we have patterns, this is taken from a very early slide on F#. Where we have patterns in the member positions as well. It's a lovely feature, but it's also really very against the principles of functional programming as well. If you can't name, abstract, and parameterize patterns, then you're just asking for problems, because it's in essence, it's not only that we can use things in a first-class way, but let's start with just being able to name a pattern, even without being able to abstract and parameterize them. And I've seen OCaml code bases, static driver verifier at Microsoft, with patterns that run over a page, trying to match some abstract syntax tree. And it started off small, and then they changed the types for the abstract syntax tree, and they made that bigger, and then they put some optimizations in, so that got even bigger over there, and they had to start pattern matching on refs or into the details of arrays and all sorts of stuff you should never, ever look through as an abstraction boundary. So patterns can be incredibly bad. So you weren't allowed to abstract on abstract types or object-oriented types, encouraging people to break abstraction boundaries, and they weren't extensible. So from a certain point of view, you should never, ever put this feature in a programming language, right? It just wouldn't make the basic grade. Okay, and I think there's a sense in which pattern matching just got shoved into functional programming in the 1970s. And Phil Wadler said we really need to do something about this in 1984 in his paper on views, and it wasn't until 2003 and 2006 that F# did something and Scala did something as well. So F# active patterns and Scala extractors, this is one version of what they look like. The double ticks are just how you write identifiers with spaces in them in F#. So even number or odd number, then there's the implementation of the active pattern, and then there's the use of the active pattern. So it's nice and simple. There's another one, let's do a bool, int, float, or string. We're categorizing some input string into the various categories. If success, then it's a bool, and so on. And then using the active pattern in a similar kind of way. So it's a lovely mechanism. So you can use it for all sorts of heterogeneous types like syntax trees and strings and XML and loads of different things. It finds uses all over the place in F# programming. Okay, I'll skip over this. So really, when I go back and look at functional languages that don't have this feature, I think that's, it's wrong. It's an incredibly useful mechanism, and it really expands the use. It fits so well with the rest of the functional paradigm. It expands the utility of pattern matching so much. I really think all statically typed functional programming languages need to have this just to get the basics right of having pattern matching in the language at all. Okay, a big focus for us was code and data. There's this type provider feature that F# implemented to bring these worlds closer together. We saw the first talk was very reminiscent of that, where you're bringing CSV data into the language strongly typed. That's a big focus for F#. We saw the type provider talk on Idris about how to take that to the next level. And we worked hard on finding a resolution for that. And there's a reason we did it, in that it's crucially important to the future of functional programming. And I think it greatly extends the reach of strong typing. So I won't go into the technical details at all, but there's a real race to real kind of operating in this space between the statically typed and dynamically typed languages is a really crucial area. So you can try and make statically typed languages more dynamic. That's what some people are doing. You can try and make them more static. That's what they're doing in adding, types to Clojure, for example. But I think the interesting thing about type providers is this really saying, let's take the notion of typing and apply it to much more broadly, to many more things. And I think the Idris talk has a very interesting approach on that as well, which is just to make statically typed languages sort of even more reflective and even more powerful in their type system. So the phrase we use is all your types belong to us. Type all the things. And in the last 2 seconds, I will pop through some of the uses of this. Entity graphs, web data sources, SQL, CSV files, JSON data, XML data, Hadoop tables, WSDL services, OData service protocols, data markets like Bloomberg or Azure Data Market, systems information on your machine, and even interoperating with other programming languages like R. There's an R type provider for F# that lets you use all the R packages and imports their metadata into F#. So definite sense of relaxation. I'm no longer terrified by the rise of data and data protocols and new data formats. It's more something we love in the F# world now. Okay, my time's up. I'll skip over the last ones. So life's much more relaxed for me now, both on the cultural side and on the technical side. Some areas still bug me. I mean, there's an enduring battle about types and complexity, I think. We can make our type systems more complex, but can we make them usable? There's one area is we have this great REPL programming on the local machine, but on the other hand, we need to be able to do distribution and cloud and scale, and being able to get a win-win between these two modes of programming is a huge challenge going ahead, and something I want to look at during the next couple of years. Okay, so in summary, I think these tensions are a point where you should look for resolution and creativity. When we find a synthesis, it's really valuable and productive. And there are these themes that run all the way through about trying to make the solution simple and unified. Sometimes you get halfway there. Sometimes people take it to a new level, as I saw in the Idris type provider talk, which makes me really happy. And finding resolutions is loads of fun. And let's all do that even more over the next 10, 20 years. Okay, questions?